In this video, I will be discussing about chemistry and degradation of macrolide antibiotic erythromycin. Now, erythromycin A is the first identified in the fermentation product of a strain Saccharopolyspora erythrea, that formerly known as Streptomyces erythreus. Now, if you look through the structure of erythromycin A, this is the structure of erythromycin A. You will find that it contains a 14-membered macrocyclic lactone ring. 14-membered macrocyclic lactone ring, to which two sugars units are attached. One, that is L-clandinose, is attached at the 3 position of that lactone ring, and another sugar D-desosamine, that is the amino sugar, is attached to the 5 position of macrocyclic lactone ring. Now, if you number this macrocyclic lactone ring, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14, and at 12 position of that macrocyclic lactone ring, two substituents are there. One is hydroxyl substituent and another is methyl substituent. And for L-clandinose, if you number 1 double dash, 2 double dash, 3 double dash, 4 double dash, 5 double dash, then 3 double dash substituents are methyl substituent and methoxy substituent. Now, if you consider that C12 substituent, that is hydroxyl substituent, as R1, and for L-clandinose, methoxy substituents, 3 double dash methoxy substituent as R2, then for erythromycin B, R1 is hydrogen and R2 is methoxy. For erythromycin C, R1 is hydroxyl group, and R2 is this hydroxyl group. And for erythromycin D, R1 is hydrogen and R2 is again hydroxyl group. Now, for L-clandinose sugar, if this R1 is hydroxyl, that sugar moiety is known as mycorrhosis moiety. And this macrocyclic lactone ring, 14-membered macrocyclic lactone ring of erythromycin A, you can consider as aglycone, and that aglycone is known as erythromycin. Now, if you compare the activity of erythromycin A, B, C and D, you will find that erythromycin A is the most active, then erythromycin B, and erythromycin C and D is half active as erythromycin A. Then erythromycin is weak base. As it is weak base, it is absorbed from intestinal environment. As it is absorbed from intestinal environment, it should pass through gastric acid environment. And another important thing of erythromycin is that it is acid unstable. So, it is quite obvious that erythromycin A or erythromycin have low bioavailability. Now, acid degradation pathway of erythromycin. In aqueous acidic medium, erythromycin form erythromycin A 12,9 hemiacetal, and this hemiacetal is formed by intramolecular cyclization of erythromycin, and this erythromycin A 12,9 hemiacetal undergo dehydration, that is removal of water. It forms a spiroketal derivative. Spiroketal derivative, that is 9,12,6,9 spiroketal derivative, and that is known as anhydroerythromycin. And this anhydroerythromycin is inactive. So when it passes through gastric acid environment, it will converted to this 6,9,9,12 spiroketal derivative, that is anhydroerythromycin. Another degradation pathway in acidic media, it formed 8,9-anhydroerythromycin A 6,9 hemiketal derivative, which on hydrolysis in dilute hydrochloric acid medium, it will form 6,9,9,12 spiroketal derivative, that is anhydroerythromycin. And this anhydroerythromycin is inactive. So to overcome this problem, that is to produce or to make the erythromycin acid stable, there are several approaches were taken, and one of the important approach, that is to prepare water insoluble acid stable salts or ester to protect the drug from gastric acid degradation. And another approach, that is polymeric enteric coating, and that polymeric enteric coating can prevent the drug from gastric acid degradation. Now there are several esters were formed by acetylation of erythromycin, that is at 2-hydroxyl group, that is 2-hydroxyl group of D-desoxamine sugar unit. Acetylation of 2-hydroxyl group produce ester, and esters were formed by propionate, acetate and ethyl succinate. Apart from its advantage that it protects the drug from gastric acid degradation, it also has an advantage that these esters can mask the bitter taste of erythromycin, and these esters can be useful for the preparation of pediatric suspension. Basically, this Erythromycin A ethyl succinate ester are very much useful in preparation of pediatric preparation. Now there are several semisynthetic macrolide antibiotic. Those are newer drug, and those are more acid stable and show good bioavailability. So this is about the gastric acid degradation of erythromycin. Thank you.